This video will demonstrate how to desolder through-hole parts with solder wick, a manual desoldering pump or solder sucker, and a desoldering gun, a combined iron and pump. It will also go over why some joints are more difficult to desolder than others. We'll start with solder wick, which is a fine braid of copper strands that have been coated with flux. Capillary forces cause molten solder to wick into the braid. I'm holding the iron on this piece to show what happens when all the flux evaporates, which is what's causing the fumes. Most metals develop an oxide layer when exposed to oxygen that repels solder, and this process gets worse at higher temperatures. The flux cleans off the oxide so solder will adhere to the metal, and in the case of wick, be drawn into the braid. When I place a solder ball on this used piece of wick, it doesn't get absorbed, but on a fresh piece, it's immediately drawn in. This is due to the fresh flux in the new piece, and that's why it's important to use a new piece of wick. To desolder a joint, first cut off any used portion of the wick, and when you use the wick, be sure to hold it by the bobbin as heat transfers quickly through the copper. Now add a small amount of solder to your iron tip. This bit of solder helps to transfer heat from the iron to the wick, acting like a heat bridge. It may seem counterintuitive to add solder to the iron when you're trying to remove solder, but without this, it's much harder to get the process started. Heat doesn't travel well through a dry contact. Now hold the wick over the joint and gently press the iron on top of it. Continue holding the wick on the joint for several seconds to make sure all the solder is removed. This particular type of joint is very easy to desolder. It's on what's called a single-sided board and only has metal on one side. In contrast, many PCBs are two-sided and have plated through holes. Boards like these are much more difficult because you need to remove solder from both sides and inside the metal tube also. The same capillary forces that cause water to climb the walls of a glass also act to hold solder in the hole. Here I've used wick on this plated through hole joint, and if we look up close, there's still solder remaining between the pin and the wall of the tube. Since this part has many pins, we need to make sure each one is completely free before trying to pull the whole part out to avoid breaking a pin or a hole. Using a small screwdriver or pick, push gently to try to break the remaining connection. Make sure the pin is completely free. If you can't break the remaining solder connection, you may need to do more wicking. If you have access to the component side of the board, try applying the wick there too. Note that I'm still adding solder to my iron tip before using the wick each time. Typically a leg will be pressed against one side of the hole. It can be helpful to apply wick on that side to try to remove the solder stuck behind the pin. Once you removed as much solder as possible, try again to break the remaining sweat joint with a screwdriver or by wiggling the part. The next tool we'll demonstrate is the manual desoldering pump or solder sucker. To use this, first press down on the spring-loaded plunger. Then align the nozzle over the joint to be desoldered and heat up the joint with the iron. Once it's molten, pull the iron tip out, cover the hole with the nozzle, and press the release button to activate the vacuum. The timing of this can be tricky as you need to engage the vacuum while the solder is still molten. If you can touch the joint on the other side of the board, it can be much easier to heat that side while holding the solder sucker on the other. This removes the timing challenge. Once again, try to break any remaining solder connection by pushing on the pin. If there's too much solder remaining to easily break the pin free, you might have to use wick to clean up what's left. If you don't have any wick, it's sometimes easier to resolder the hole and try again rather than continue to use the solder sucker on a mostly empty hole. If the joint is mostly empty, it will be difficult to get the remaining solder completely molten with the iron, and also difficult for the solder sucker to create much of a vacuum. Some joints are much more difficult than others to desolder. For instance, when you have a small hole with a very small clearance. Also, when a hole is attached to a ground plane, it can be difficult to heat up the joint sufficiently. A large component like this capacitor also adds to the heating requirements. In this case, if you only have wick or solder sucker, your best bet is to use a higher temperature setting. Unfortunately, the higher the temperature and the longer duration of desoldering operation, the greater risk of damage. For cases with large ground planes or boards with 4 or more layers, a preheater can be used with a stand like this to warm the entire board before applying heat with an iron. Another difficult condition results from poor quality boards. On this particular board, almost any amount of force used to break the remaining solder connection after wicking will damage the plating on the through-hole. For all of these tough cases, or if you need to do a lot of desoldering, a desoldering gun is the ideal tool. It has an integrated iron and trigger-activated vacuum pump. To To use it, first make sure there's a good amount of solder on the joint to help heat transfer into it. Consider adding more if the joint is very small. Adding some flux at this point will also help. Now bring the gun down on the joint and wait for the solder to melt. Once it does, start moving in a circular pattern, but avoid pushing down on the pad. Then activate the vacuum. Continue moving the tip in a circular pattern to help clear solder from all sides of the pin, and then lift up the nozzle. The air and circular motion will help prevent the pin from refreezing to one of the sides. When doing ICs, it's a good idea to skip pins to avoid thermal buildup in the part. Finally, some alternative methods and a few more tips. With solder wick, it can be very easy to damage a pad by moving the wick after it has frozen to the board, but many times you can remove components without first removing the solder. For components with nearby leads, you can heat both at once with an iron and simply pull the part out. On resistors, you can pull one leg out at a time. For components with more than 2 leads, a hot air tool can be used to get all pins molten at once. A special low melting point solder called chip quick will let you do the same thing with a normal iron. Just melt in some chip quick into every joint, alternate between each joint to keep them all molten, and then pull the whole part out. The chip quick allows you to keep every joint liquid all at once. If you're willing to sacrifice the part, simply cut each leg, remove the part, and then pull each leg out individually. It's a lot easier to clean a hole that doesn't have a lead in it. Many of these approaches will be faster and pose less risk to the board than trying to desolder each pin individually.